Okay, we are going to start talking about how to solve both exponential and logarithmic equations. Today we're going to just work on the exponential equations. And we've already solved some exponential equations. For example, an exponential equation like this. If you were given this exponential equation, what would you try to do in order to solve it? Yeah. Yeah, we have to get all the bases the same, don't we? Right? You remember that? Get all the bases the same. So you look at 27, 81, and 27, and you say the common base there is 3. Okay, so of course 27 is going to be 3 to the third, so I get 3 to the 3x, is equal to 81 is 3 to the 4th times the 4th root of 27 becomes 3 to the 3/4. So over on the right-hand side, what do you do with those exponents? You add them, so you get 4 and 3/4. And now the bases are the same, so how do you figure out what x is? You take 3x and you do what? Yep. 3x is equal to 4 and 3/4. So that's what, 19/4. So dividing by 3 is the same as multiplying by a third. So x would be 19/12. Right? You remember how to do that? So we've already solved these equations. So let me show you another one. 5 to the x equals 20. So what are we going to try to do first? Get a like base. What's the like base between 5 and 20? They are both powers of what? No? You can't get a like base, right? So your first step is to look for like bases. But if you don't have them, look for like bases. If you don't have them, if none, then what are we going to do next? Well, do you remember when we started the whole log business and I said for the rest of this chapter we're probably going to be doing a lot of going between log form and exponent form to log form, all that kind of stuff? Well, we're going to do it again. Now, I don't want to put this in log form per se, because if I put it into log form, what would be the base of my log? 5. Now, is a base 5 in a log going to allow us to calculate it with our calculators very easily? No. What base do we like to have if we're going to use our calculator? Base 10, right? If we have base 10, then our calculator is going to be able to help us. So, if you don't have like bases, then what you're going to do is you're going to isolate the base to the power, and then you're going to take the log of both sides. And let me show you what I mean by that. When you take the log of both sides, you can take the log with whatever base you want. Because you know with an equation, as long as you do something to the left side, if you do the very exact same thing to the right-hand side, won't they stay equal? Okay, so let's take the log of both sides and let's choose base 10. Why? Because your calculator is going to help you calculate your final answer and get a decimal approximation. If I take the log of both sides, it's going to look like this. The log of 5 to the x is equal to the log of 20. Now, how in the world is taking the log of both sides going to help me solve this problem? Think properties of logs. Look at the left-hand side and think properties of logs. Mm-hmm. That's right. Remember that exponent can come out in front as a multiplier. So it becomes x times the log of 5 is equal to the log of 20. Why does that help? Yes? Well, you could do that, change 20 into 4 times 5, but now we can divide both sides by the log of 5. And x is going to equal the log of 20 divided by the log of 5. Now we can make that into a decimal approximation, can't we? Because now we can use our calculators. So go ahead and do log 20. Now make sure after you do log 20 you close your parentheses before you hit your divide. And then divide by the log of 5. Are you getting about 1.86? And there's your answer. Here's how you check it. Take 5, raise it to the 1.86 power. You should get pretty close to 20. It won't be exact because we rounded 1.86, but are you getting pretty close? Yes. Okay. Any questions on how I just did that? Let's see. I've got a few more examples, but let's just let's look at the last one that I have down here for a minute. 2 times 1.5 to the x power equals 6. Can you get like bases? No. What should we do first? Okay. Yeah, we have to get that 1.5 to the x by itself. So divide by 2, and we get this. Now what should we be doing? Take the log of both sides, right? Why is taking the log of both sides so nice? Because that exponent can do what? Come out in the front. And as soon as that exponent is out in front, can you solve for the x? Yep, all you have to do is divide by the log of 1.5. Could you punch that into your calculator then and get a decimal? Okay. Any questions on these equations? Yes?
Could you write it as the log of divided by 1.5?
Good question. Can that be written as the log of 3 divided by 1.5? No. Okay? Because those are two separate logs. It's the log of 3 divided by the log of 1.5. Now, I think I need to be putting your assignment up here. It's on page 464, 1 through 21, the odds. Do all of these algebraically. Some of them tell you to use a graph or a table. Just do them the way that we did them up here. And 48, 50 through 52, and 53 through 59 odd. These last few are mental math, and you should try to do them mentally. Try to not use a calculator if that's at all possible. All right, good work today.